Hold on, people. We're having a study moment. Do I have anything good for a study moment? Yes. Yes, I do. When you hear that sound, that means study. Here are all the speeds. Let's use this chart to really ramp up on our information regarding connection speeds. Some of this I'm going to review. The wireless we're not going to talk about. So this is good because it shows you all the speeds in order from the fastest transmission speed to the slowest. And it includes your wireless, but we have a whole subject on that. So right at the top, your top contender, and will always be for the near future, Thunderbolt. 40 gigabits per second. Blazing speed. It can also use a USB-C connector, or it can have its own Thunderbolt connector, which is always designated with a lightning bolt. Then we have Thunderbolt 2 right behind it, so top 2, and that's 20 gigabit. But we already said 20 gigabit has been matched by USB 3.2. Runs at 20 gig also. Then we move down to 10 gigabit. Well, that is our USB 3.1. The one says 10 gigabit. Here we're looking at our SATA drives. The next thing we see is our SATA drive. So we're going to learn that in our hard drive class. So I'm just going to move past that. So then we have 5 gigabits. What did we say 5 gigabits? USB 3. 3 was 5 gigabits. Moving down, we're not going to talk about the Wi-Fi or eSATA at this point. Oh my Lord, that was crazy. Here we go. We have our Lightning. That is Apple proprietary, and that is 400 megabits, just like our USB version 2 is 480 megabits. So that sounds like a question right there. Choose below all connectors that run at the speed of 480 megabits. Answer, Lightning and USB version 2. All right, so that could definitely be one of your questions on your test. USB version 1, we said ran at 12 megabits. Remember the higher number, don't worry about the lower number. Then we have our Wi-Fi channels. We're going to go over that in our own chapter. And last but not least, oh my Lord, look how slow this is. Bluetooth. Now, it's got a couple versions, I believe, since this, but you can notice that a Bluetooth does not have a lot of bandwidth. 3 megabits per second. That handles listen to audio, but that's no way to transfer data. And the least amount is NFC. What is this near field communication stuff you speak of? Well, that's your wireless pay. So if you ever use Google Pay, Apple Pay, any other type of technology pay, and you have to get your device, it's like millimeters from the actual point of sale, and boom, it automatically withdraws your money from your account. Just like my wife. I should have used my drum. All right. No, actually, that's what NFC is for. Wireless payment. Oh, that one's growing too. Now, I told you I wouldn't leave you out in the dust with the DVI. And there's a lot of different iterations of DVI. So, really the important things are you have to be able to visually see the format, the connection type look, and then want to be able to explain if that is DVI A. A is for analog signals only. So really, are we using any DVI A anymore? No. DVI D is digital. Digital signal, single link, or digital dual link. One allows for so much throughput, the other one allows for more. You don't need to know the throughputs. I just want to explain why they look differently, have the same D designation. DVI-I. DVI-I is both digital and analog in the same connector. So if you're running some type of analog equipment, you can use a DVI-I and it can support the analog version. And then if you're actually splitting that to another piece of equipment that's using digital, the I part will also support that. So it supports both, which is very nice. And there's a dual link also available, but they're only going to ask you one of these. So you're going to have to be able to know DVI-A analog. D, look at the bottom one here, is the most common. That's for digital only. And then DVI-I, which allows for analog and digital. Good job. You have just covered your DVI standards for the test. Storage connectors. We already went through some of them, but just so you have another idea, we're always going to reinforce in this class. Here is our SATA data connection where our 7-pin cable goes back down to our motherboard. And here is our power connection. It's a 15-pin power, flat power connector, which we'll be very familiar with after our power supply portion of class. Here is an old SCSI connector. Ugh. And a Molex. Molex power is for your older devices, like we said, your IDE hard drives, the old magnetic ones. They use the parallel cable. That's what these are. So it's very unlikely you're going to see new power supplies with a rail, which is a connection power to the power supply, that has Molex, that it supports Molex, but you may. Here's that RJ45 connector. You're always going to see some part of RJ45 on network equipment because even though wireless has grown tremendously and is very fast throughput, nothing beats an old wire connector, right? Because it's sturdy. It's much more sturdy. It's not receptive to interference, to a lot of obstacles or blocks like walls. And it doesn't reflect. It goes directly through the cable, directly to your machine. So an RJ45 connection is to plug in any type of regular standard network cable, also known as a patch cable. And then you would plug that directly into the wall, which feeds through the entire building, back down into the data room, gets punched into a punch down rack, gets fed into a switch, switch gets plugged into a router, and we just went through the whole thing of LAN wiring, but we're going to have a whole chapter on that too. Now, what is this dog over here? What is this RJ11? RJ11, what is that out there? Anyone know? Anyone? Bueller? Anyone? That's right, telephone systems. Whoo, doggy, back when the old telephone dial-up. Ching, ching, ching. You got mail. That's RJ11. So it's very hard to distinguish. This one is actually a little larger than this one, even though they look identical here. So RJ11 connections for real old telephones that plugged into the wall, that's what that is. Okay. Going over some information about expansion cards in general. It's a printed circuit board that is installed in a slot on a system board to provide special functions for customizing or extending or expanding a computer's capabilities. Also referred to as adapter cards, input-output cards, add-in or add-on, onboard cards. A lot of different terminology. Just call them expansion cards and you'll be fine. So we see a whole plethora of expansion cards down here. Some are for sound, some are for USB, some are for graphics, obviously. That's going to be your most common type of expansion card is your graphics card, which is going to use that by16 PCIe slot. This one is a network adapter card right here. It's to plug in a cable, RJ45 connector on the end, into the network adapter so you can plug into a wired network. Oh my Lord, it is question time again. Let's get it going here, people. Let's get it going. So, in this graph, identify these different types of ports. So let's identify them. Take a second. What do we have here? What are we looking at right here is what they're actually identifying. Let me, oh, that's both here. And then what are these called? So when we move here, it tells you everything. So moving from left to right, we have our USB. And how do we know a little bit more information? It's not just USB. That is correct, Tony. It is USB point 3 because we see the blue on the USB port itself. Here we have our DVI. So our video port is DVI. Here we are actually looking at our USB ports, again, and our RJ45. And then we have our sound port. So there's a lot of different ports here. And this is what you want to do. You want to just be able to visually sit and recognize what these ports are and then remind yourself of some of the information, which I'll do right now for you. USB 3. USB 3 ran at 5 gigabits. US 3.1, 3.1, 1 ran at 10. USB 3.2, 2 ran at 20. So we went from 5 to 10 to 20 gigabit in the versions on our USB connections. Good job, everybody. You are speaking with a junior technician. He is not sure what he's meant by a keyed connector. What are you going to tell that guy? Don't ask me a question? No, don't do that. Always be kind to your friends and your colleagues. A keyed connector, as we already spoke about, a keyed connector says it has a catch or a slot to ensure that it cannot be inserted in the wrong direction or used for an incompatible port. So you don't want to make sure you're making a mistake. Well, keyed connectors make sure you don't make that mistake. All right? They're like a physical wizard for software. They make sure you don't turn in the wrong direction when you're trying to do something. All right, what is the nominal data rate of a USB port supporting Super Speed Plus? Super Speed Plus. Plus is your USB 3.1, which is 10, but devices sporting 3.2 can go 20 gigabits per second. They can also use that new C cabling where you can turn it upside down or it doesn't matter anymore, thank God, because that was always a pain. USB-C. USB-C ports and cables are compatible with Apple Lightning ports and cables. What? That is a big no-no. There is no way Lightning is going to be compatible with USB because we know how Apple is very proprietary. It's not going to have it happen. So why would you install an I/O adapter card or an expansion card? Why would you do this? Good example. To make more or different kinds of ports available. Let's say you wanted to introduce SCSI into your computer. Well, it naturally won't have a SCSI actual connection port. Or maybe you want to add more USBs. I don't know why you wouldn't just put a hub, but you could do that.